So now, one of the nice things about lines, since they're relatively easy functions to work with, we usually try mathematically modeling a lot of situations with lines. That's not always the greatest thing to do because not everything is linear, but it is the easiest thing to attempt. So here what I have is, to get us started here, is I've got a function, p of t equals negative 9t plus 342, and it models the population of Truchas, New Mexico since the year 2000. Let's use it to answer the following questions below. So the first question asks, is the population increasing, decreasing, or I should say constant there. Sorry about that. All right, and in this case, this all happens to deal with the slope. And if we look at this, right, I know we're using t's, but this pretty much mimics, okay, our f of x equals mx plus b. We're just exchanging f with p, and we're exchanging our input, our independent variable x, with the independent variable t. So it's just basically our slope-intercept form, just in some new variables. So our slope, right, is sitting right in front of that t, so it's negative 9. So this means that the population is actually decreasing. Okay? What is the meaning of the slope? Well, negative 9 basically means negative 9 over 1. And this is basically a linear model, right, since the year 2000. So we're going to assume we're in years. So this basically means that we lose 9 people, right, per year. So that's what the meaning of the slope would be in this case. The y-intercept, well, the y-intercept is the point 0,342. And that would basically mean, again, we're starting in the year 2000. That's when t equals 0. So that basically means that the population was 342 people in 2000. So when they started this model, when this model started to be used, the population was initially, we call that kind of the initial population, right, was 342 people. Okay? So next question. What will the population be in the year 2020? Now again, we have to be very careful here, right? Because we started this model in the year 2000. So in 2020, that actually means t is equal to 20. So to do C, to use my function language, right, we're basically trying to find what is p of 20. And so just like we've been doing in the past, we plug that value in. I think we get a negative 180 there. I will bust out my graphing calculator for that real quick, and it looks like we get, oops, let me quit out of there, right? So 342 basically minus 180, and it looks like we have 162. So P of 20 is 162. So there's 162 people, right, in the year 2020, I guess this year. Again, we're assuming the model's working and it's valid. We can always go out there and check. Again, we are having a census this year, and we can either readjust our model or we can, say, hey, the model's working. So there's A, B, and C. D, in what year will the population reach 0? Okay, so again, to do D, we're essentially asking, when does P of t, when does it equal 0? In essence, it's a y-intercept. So, an x-intercept. So what we have to do here is take our function, negative 9t plus 342, and set it equal to 0. To solve this, I'll begin by subtracting 342 from both sides. That gives us negative 9t equals negative 342. Divide both sides by negative 9, and we get our t value. Again, let's just go ahead and reach out for the calculator. 342 divided by 9. Again, a negative divided by a negative is a positive, and what we end up getting is 38. So t is equal to 38, right? But they want to know what year, right? Not how many years, what year. Well, we started this model starting at 2000, so this basically means that this model, right, there's going to be nobody in Truchas, New Mexico, according to this model, in the year 2038. So 18 years from now, if that model holds true, there'll be nobody living there. I guess it'll be a ghost town. Okay, something that's a little new, especially in this section when we're trying to apply things, is this thing called an implied domain, right? So what is the implied domain of this population function? The reason why this is important is due to the fact that we know lines, right, they have no red flags. So the domain is usually negative infinity to infinity. However, right, if we were to actually use all these t values, we're going to have to be careful because this eventually becomes less than 0. It becomes negative. And as far as this is concerned, that doesn't make any sense due to the fact that you know, we can't have a negative population. Either people live there or they don't. And if nobody lives there, we cap at 0. So we actually have some inside information here. We know that when t is equal to 38, or the year 2038, my population reaches 0. So if I go past 238, that means that the population is going to become negative. And we don't want that. So that basically tells us that our right bound is 38. What about our left bound for this domain? This is letter E. Well, everything starts at 0, right? That's the year 2000 and the year 2038. So this model is only good, right, when it starts at the year 2000, which corresponds to 0, and when it reaches 0, which is 38. If I go this side of 0, or if I go this side of 38, my population again becomes negative, and that's not good. All right, because we don't want that to be good. So even though the function itself, if this had no meaning, right, no meaning at all, you would correctly tell me that the domain is everything. But because this has meaning, we're talking about population over time, right? We have to be careful about what the domain is and what we actually put in there. So anything from between 0 and 38. So let's go see all this on our handy dandy graphing calculator, right? So we're going to go graph this. So we're going to hit y equals, and we have, you make sure you're pressing the right negative, right? It's this one down there, right? So we're going to press negative, and then we have 9x plus 342. Now again, the calculator doesn't handle, right, t's, so that's why that was important. We're just interchanging t's for x's. So negative 9x plus 342. Now we have to be careful, because if I graph this right now, right, I'm not going to see any of my graph, because we already know that the y-intercept is at 0, 342. So it's way up there somewhere. So, and we also know that we're going to start this at 0 and go out to 38. So we got to go play around with our window. So my x-min, how about I just so we can see the axis, the y-axis, how about I make it -5, and I'll let my x-max be 50. All right, so we'll go a little bit past 0 and a little bit past 38. And we'll go in steps of 5. And then, right, my y-min, well, again, the population that's its lowest is going to be 0. So how about I just make that -10? Let me go a little bit bigger. Let's go -50. And the only reason I'm doing this, you'll see in a moment, is I want to make sure we can actually see the x-axis. X max, well, we start at 342, and then we start to decrease 9 per year. So the top half, right, why don't we just go all the way out to 300, and let's go even further. Let's go out to 400, right? And we'll go in steps of 50. All right, so there's our viewing rectangle. So when I go graph it, there's basically the graph of my line. And so we can basically see everything that we said, right? Number one, we notice that the population is in fact decreasing. It's on its way down. We know what the meaning of the slope is. The y-intercept, well, it's occurring at 0, 342. And again, if you wanted to make sure, we can actually go to calculate, put in a value, let x equal 0, and there's 342. So we verify the y-intercept. What will the population be in 2020? Well, for our model, that's for t equal to 20. So again, second calculate, let's do a value, let's put it in at 20, and we have 162 people, right? So there, that validates what we said in part C, that the 162 people in the year 2020. What about this part here? What's the x-intercept? Well, let's just go ahead and use the value of 38. So y calculate, second calculate a value at 38. And you see that we're at 0. And what you also see is the implied domain, right? So down here, right, when we go past 38, we're negative. When we go past 0, we're still positive, but that, again, we're starting at the year 0, and so we're not really worried what happened in the past, right? Perhaps, I'll start the function, at 1990 or the 1980. Maybe the function didn't work past then because it was declining in a different way. But there you can kind of see this function only being valid in the first quadrant. Starting at the y-intercept, going down to the x-intercept, we actually have some data that we can see and that makes real life sense. All right? So there you have it. There's our first word problem. A lot to it. We even brought out the calculators. Right? We'll do a couple more later in some new videos.